Welcome to this new tutorial from our mobile multi-chain game series. Today, we'll be implementing security measures for our Solana program. In our last tutorial, we implemented a secret 32 bytes hex key in our EVM compatible networks Solidity contract. For this solution, we needed to provide the correct hex key stored in the contract, which we hard-coded into our client app using the env file. Our security solution for the Solana network will be similar, with the difference that in Solana, we can define multiple signers in a transaction with only one of them defined as the payer. This way, we can hard code a public key into our Solana program and require that address to sign the transaction even if it is not the payer. This way, only by possessing the secret key, which we can hard code in the client's app, can anyone save info on the blockchain. Let's see how this works. Let's copy the repository from our last tutorial, link in the description, run git clone with the repo address, and navigate to the DynoGrow folder. Create a .env file with the variables you see on screen. Go to quicknode.com and copy the RPCs for each of the chains we are working on and copy the contract addresses and the EVM key you created in the previous tutorial. Now let's create the Solana account we're going to use as a second signer and security check. To do this, we're going to use the Solana CLI. You can find in the description a link to the Solana docs page with installation instructions for each operating system. You should see the Solana version correctly displayed in your terminal if the process was successful. Now we can run from the terminal Solana keygen new. Hit enter for no passphrase. Now you'll see on screen a root where a JSON file with the key pair generated has been created. Navigate to this root and open this file. We're going to copy the key pair consisting in a list of numbers and paste it in the env file with the name SolanaSK as you see on screen. Remember, this is the master key to access your SafeScore function in Solana, and you should keep it safe and secret. Please also keep your public key handy as we're going to need it soon. Now let's start working on our Solana program. Open the program we created in the tutorial, Smart Contracts Integration with QuickNode Flutter Game Series. Part 2. If you didn't follow along, we invite you to do so, link in the description. You can also follow the link to the SolPG program in the description. Don't forget to import it. The first thing we are going to do is to add a new account to our SafeScore and update score structs. We'll call it security address, and this account will be required to sign the transaction along with the user account. Now, let's create a function validate origin that will receive a string security address and will return a result. Inside our function, we'll define a string DynoGrow address where we are going to store the public key of the second signer we are setting up. Now, if the address received by the function is different from the stored address, we'll set up this invalid authority account message and return an error code, invalid account data, which we'll define now. Else the function will return OK. At the bottom of the code, we'll set up the error code with the invalid authority account message, as you see on screen. Now, we'll simply call the validate origin function in both our SafeScore and update score functions, with the security address defined in the respective context SafeScore and update score, taking the key parameter and converting it to string. We should also place this quotation mark in the end to stop the program execution in case of an error. With our contract ready, let's run build and deploy. And let's update our Solana program address in the env file with the new account number generated. Now it's time to see how this works from the client app. Let's open our SafeScore.dart file got to the SafeScore Solana function, and first of all, we'll read the secret key from the env file. Then, we'll get rid of the unwanted characters and convert our string to a list of strings. In our case, a list of characters, by using the comma as separator. Now we'll convert each character number to integer, so we have a list of numbers. From this list, we only need the first 32 items. These correspond to the private key. Now, we need to convert our variable to a list of bytes. And finally, we can construct our ed25519hd key pair security key using the fromPrivateKeyBytes method. With our key pair ready, we'll add a fourth account to the accounts list parameter in the for method instruction. This one corresponds to our security key, public key, and marked as signer with the isSigner parameter. Lastly, we need to send our security key as a second signer in the signers list of our send and confirm transaction method. Before we test this out, let's fix our code so that we can return a flag indicating if the transaction has errors or not. We'll change the return type of our SafeScore function to dynamic. Change our result variable accordingly, and also the return type of our SafeScore EVM function. Now we're returning our result in an object with the respective flag to handle the errors like you see on screen. We'll do the same for our Solana function, opening a try catch for the transaction and sending the result object. And let's not forget to change the return type of our sendScore Solana function. We are ready to test our security measures. Before running our app, let's open our fallingboxes.dart file, and in the display result function, let's change the type of the first parameter to dynamic and modify the result variable to access the result field in the truncate string function. Change the condition for displaying the transaction completed or failed message to rely on the info present in the error field of the result parameter, and modify the clipboard copy function to also receive the result field of the result variable. Right now, if we run our game and try to save a score to the blockchain, everything goes as expected. But let's try what happens if we send the wrong address. In the command line, generate a new key pair file using Solana keygen_new, open the file and replace the Solana SK variable in uenv file. Now run the game, and if we try to save a score, it will return a transaction failed result. We copy the result and can see the message invalid authority account. Try it for yourself. And that's a wrap. We hope you are inspired building your own multi-chain game. Like, subscribe, comment, and share. Let's build the Web3 future. See you in our next video.